everyone. Today I wanted to do my video discussion on how the respiratory system regulates blood pH levels. It's mainly done through this reaction that's shown at the very top of the screen right here. About 90% of carbon dioxide is transported throughout the body via the reaction of carbonic acid and bicarbonate ions. The first step in this process is carbon dioxide enters the bloodstream. Um, and from the tissues, and it combines with water in the bloodstream where it forms this carbonic acid or H2CO3 shown on the right side of your screen. The carbonic acid then dissociates into hydrogen ions and bicarbonate ions. Once this dissociates, the bicarbonate ion travels through blood vessels to the lung, where that bicarbonate ion then combines with a hydrogen ion in the blood in the lungs and becomes carbonic acid. That carbonic acid then once again dissociates and becomes carbon dioxide and water. The water will stay in that blood capillary in the lung, but the carbon dioxide travels across this respiratory membrane shown by this orange line right here, from the capillary into the alveoli, where it is expelled from the lungs via expiration. And then, as I stated earlier, that water will stay in the plasma. Another way to think about this is pulmonary ventilation in the brain, and how it's maintained. So this was something I took from the chapters in our book, chapter 22.3G. I did read up on it, but I might miss some points. So if you can just let me know what I'm missing, or maybe I didn't quite get it correct, I would appreciate it. But the first step in this is carbon dioxide in the brain crosses the blood barrier into the CSF, or the cerebral spinal fluid. Once it's in the cerebral spinal fluid, it reacts with water. And again, we see that same reaction as we did in the capillaries. So the water combines with CO2 to create carbonic acid, and then it dissociates into hydrogen ions and a bicarbonate ion. Once there, the CSF doesn't contain enough protein to buffer that hydrogen ion. So hydrogen ions remain free, and they stimulate chemoreceptors in the medulla oblongata, which mediates about 25% of respiratory response to the pH of blood. Now, how do we know that hydrogen ions stimulate the chemoreceptors and not the carbon dioxide that diffuse into the CSF? We know this because when the pH changes, there's a strong effect on respiration, but there's not as strong of effect on the carbon dioxide. Now, one way to show this is through alkalosis and acidosis of the blood pH. So the typical blood pH is going to be about 7.40. It ranges anywhere from 7.35 to 7.45. If the pH of blood is under 7.35, it's considered acidotic. If the pH of blood is greater than 7.45, it's considered alkalosis. Now, the typical partial pressure of carbon dioxide in the blood is going to be anywhere from 37 to 43 millimeters of mercury. If the partial pressure of carbon dioxide is greater than 43 millimeters of mercury, it's considered hypercapnia. If that partial pressure is under 37 millimeters of mercury, then it's considered hypocapnia. Hypocapnia causes alkalosis, and hypercapnia causes acidosis. So this is just yet another way to show that the respiratory system, or pulmonary ventilation, which is also breathing, causes and regulates blood pH levels. So when the pulmonary ventilation does not match the rate of carbon dioxide production, a pH imbalance occurs. Now, how does pulmonary ventilation fix this? There's two specific reactions we can use to show this. In terms of a homeostatic response to acidosis, and if we remember, acidosis is going to be when the blood pH is lower than 7.35. Um, it's considered the homeostatic response is called hyperventilation, or eliminating carbon dioxide faster through expiration than the body produces it. This very top reaction is what occurs. Hydrogen ions are consumed on the very right side, which causes the hydrogen concentration to decrease, therefore rising the pH blood level, and the blood pH goes from acidotic to normal. So in this case, the reaction shifts to the left. Now, if the blood is alkalosis, the homeostatic response to this is going to be hypoventilation, which allows carbon dioxide to accumulate in the body faster than we can expire it. So in this case, the reaction occurs to the right. So hydrogen accumulates. We can see at the very end of this reaction, hydrogen ions are free. This causes the hydrogen concentration to increase, the blood pH levels decline, and the blood pH goes from alkalosis back to normal. So because of not only these reactions, but the very first one we went through, the amount of carbon dioxide in the blood expired through breathing directly affects hydrogen ion levels in the blood. By facilitating removal of CO2, or in this case, in response to alkalosis, um, allowing it to accumulate, the respiratory system helps regulate these blood pH levels. I hope this video was informative and helped you understand the regulation of blood pH via the respiratory system. Like I said, if I missed anything or if something didn't make quite sense, please let me know. Thank you.